Hello and welcome to the loadModel tutorial. The last tutorial was about WebGL and primitive shapes in p5.js. Now we're going to look at slightly more complex models. So the thing about p5 is you can only load models that are up to like 5 megabytes or something. So we'll do that, and then I'll show you a way in which you can do more complex models and also use the p5 library. There are a couple ways that you can get a model to actually work with, and one of them, and the best solution for us artists and designers and creators, is to just like make our own model. And I like VR. Actually, I have a couple headsets right here. So I like to make models using Gravity Sketch VR and put them into this thing called Sketchfab. You can also use Blender or any other like 3D modeling software that's out there. There's like CAD programs as well. There's really a lot of software options available. So, but a lot of people use Blender, so I would go that route if I were you, although there's a pretty steep learning curve. But in any case, there are also some websites that you can pull other people's models from. You can buy 3D models, and you could search for 3D models. So Teapot. I'm just doing Teapot because that's like in P5 like what they use. So it's like, it's also very like a nice simple shape to use. So yeah, you click on a model that you like and you sort of see download 3D model here. And it's got like different formats available. Unfortunately, so GLTF is like, I guess what's most used these days, but we have to use an OBJ or an STL file. And I like to use OBJ because all of the programs that I use work, like OBJ works with that. So I just stick to OBJ. You can see here like the model is made of triangles and vertices. So we'll look more at this later, but in the WebGL tutorial we talked a little bit about how like 3D models and 3D objects are made in the digital environment, and it's with points, these vertex points, and the vertex points, they make up subdivisions or triangles. If you're using p5 on the on a browser, you want something very low in triangles. So if you just like Google OBJ models, you'll see Sketchfab, you'll see Turbo Squid, which seems good. I haven't used it very much. Search Teapot and see what comes up. So they've got like these packages full of like, you know, not just one, but a lot. And some of them cost money, right? So yeah, you can just look around. So we're gonna come over here and we're gonna go to sketch files, and we'll just do upload file as if we would an image. And here I've got my load models tutorial, and I've got this teapot here. And you see that the teapot object is pretty small. This object is also what we're going to use a little bit later, but let's try to upload this Sid Smooth 3D. It's a little bit bigger. So it gives me this X file is too big. So I'll show you how to fix this problem. But let's go back and upload and grab our little simple teapot, open it. It gives us a check sign. Woo! So we're good to go. And you see it over here, right? Teapot.obj. So we're gonna use the load model function, and you can load a 3D model from an OBJ or STL file. It needs to be placed inside of preload like our images, and you can read more about it here. So you could come here and like take that and copy and paste it and just like tweak around the stuff, but tweak around the functions and the parameters and stuff. But we're gonna write it from scratch. But here it's nice to see that load model. It's the path to where the model is. So say you have a folder and all of your models are inside a folder, you'll just like call that folder and do a front slash and select the model in the folder. Normalize we need to know. So normalize is a Boolean. If true, scale the model to a standardized size when loading. So we'll just use the true Boolean, and I'll show you what it does. But it'll just like scale it properly in proportion to the canvas. So yeah, let's do that. Function preload. And you'll say, well, first we have to make a variable. So let teapot, pretty similarly to the examples. And what is our teapot? Our teapot equals loadModel. And the place in which it is, or the name of the model. So our name is teapot.obj. And then the second parameter we're going to set to true. And this is going to scale it to the canvas. Down here in create canvas, we'll just change this to window inner width, window inner height, like we normally do. And then our third parameter is WebGL, which we learned in the last tutorial. So that's going to make us have a 3D space with its origin point of the center. So you press play and nothing pops up because we need to draw our model. So I'm just going to make, also while I'm up here, the color mode. I want to use hue, saturation, and brightness. And then that way here, I'm going to make my background gray. And the hue, I'll just put 0, which means red. But if I put 0 for saturation, it means white. And then if I put 50, it decreases the brightness level of that white. So now we've got like a gray looking background, which I like. And I want to draw my model, or draw my teapot. And that's just using the model function and then the variable name of the model. And we'll press play, and look, boom, we've got our model. So we'll use a no stroke to get rid of the lines, and it just looks white because there's no lighting or anything. We don't even have a material on it yet. So quick note, up here in the loadModel function, let's see what taking away true does. So it makes it like really tiny. So yeah, it's just like scaling the object to the, you know, to a good proportion size with the, let's just use this scale function to scale up the model a little bit. Width times 0.003 is what I'll do for right now. Yeah, that seems good. Actually, I want to make it like slightly bigger. Cool, so let's give it a material. And the material, we're going to use specular material. And specular material, if you come over here and you say specular material, is a reflective or shiny material. The shininess is also controlled by the shininess function. So when using specular material, you can use the shininess function with it. Like ambient material, the specular material color is the color of the object will reflect under ambient light. So you can use ambient light, but we're going to use directional light. So you can see here what the specular material looks like. It's like a shiny, like sort of plasticky look in this case, because you're changing the shininess. We're going to set it at a gray colored material. Gray material on a gray background. And in order to see it, we have to incorporate lights. So lighting, and we'll do directional light. And the parameters of directional light, which we went over, is either, it's got 6 parameters. So it's HSB or RGB if you're using that. And then the last three are the X, Y, and Z direction of which the light is like pointing. So we talked a bit about that in the WebGL tutorial. So yeah, I'm gonna make the light just white. So 0, 0 for saturation and 100 for brightness. So very bright white light. And then I'm gonna put 0.5 for the X location. So it's gonna be like a little bit this way, like a little bit towards me in space. Because when you go far away on the Z-axis, just keep in mind that that is going in a, like, I believe a negative direction, and this way is positive. Can't remember. But I'm just gonna put 0.5 for the X direction, 0.5 for the Y direction, and a negative 0.5 for the Z direction. And you can play around with this, but this is where the light is, and I actually already knew because I've been playing with that. I want to animate my teapot, so I'm gonna say rotate X, and inside of this, the argument would be an angle, so you could, and we're also gonna use rotate Y as well, so that it doesn't just rotate on the X axis, but it also rotates on the Y axis. So we'll see like all parts of the object. You can also do a rotate Z function if you want. But inside the argument would be an angle. So you could like make a variable called angle like we normally do, and you could animate that angle and have a moving number. Or you could use this function called frame count, which is what they do in the tutorial. And so we haven't covered frame count, and so I just want to cover this. So do frame count times 0.01, or let's just see what frame count does. Frame count is, and let's comment that out real quick. It's counting the number of frames that occur every time the sketch is played. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So whenever you just use frame count, it's moving really quickly. It's counting 1, 2, 3, 4, 5, 6, 7, 8, you know? So you have to slow it down a little bit by multiplying it by 0.01. So all that does is it slows it down. So now you got 1, 2, 3, 4, 5, 6. So the animation is happening because this number is moving, and it's moving slower because we're multiplying it by 0.01. Cool, so now we can see all parts of it. Let's go back to the material and let's play around with shininess real quick. So shininess, how much do I want it to shine? So the first, like it can go as little as 1, and that is pretty, like it looks a little bit metallic, right? So I want it to like have a plasticky look. So if we, just go up and you play around with it and see what does 10 look like. It's a little less shiny. So I'm gonna put it at 20, and I'm not sure about what the highest number value you can go to is. Like, I don't know, does 500 work? I don't think it changes very much, but you can play around with that. I had it set at 50 and I liked it there. So this is 50, this is 1. So this is metal, and this is ceramic or plastic maybe. That's how we load a simple OBJ in P5 using the web editor. So now we're gonna see, well, I 3D scan my face and I want to make an interactable 3D scanned face. How do we do that if it's bigger than 5 megabytes? Part 2 of the tutorial is working with OBJs that are a little bit more complex. Let's move over into Visual Studio Code and work with P5 there. So I've opened Visual Studio Code, and this is the entry window. And I just need to do open folder. And in my VS Code folder, I'll just go to my Spring 2023 and do a new folder and save my project here. Scan 3D scan demo or something better, but that's what I came up with. Cool, so we've got that here. So it's really easy to use P5 in VS Code. All you have to do is come in the Explorer here next to our folder that we have saved and do new file. And if you put this next to P5 window, like this, all we have to do is like write over these, like copy these files, and it'll act and function the same way, more or less. So new file, and the first file is going to be the index.html file, and you see it changes that icon there. And then you could come over here and copy all of this and just paste it in here, and then make a second file, and you'll just call that the sketch.js. And I'm going to start from scratch here, but you could copy the teapot over as well and just work off of it that way. So copy it and just paste that. Could write it, but I'm too lazy. And then the third file, it's going to be the style.css. And we'll just take that, Control C on Windows, Control V, and paste it here. So now we've got P5 in VS Code, and we really don't need to work with it over here anymore, although we do have the references pulled up, which could be helpful. So save all of that, and now we're in our sketch, and we just need to upload our OBJ that wasn't able to upload on P5. See if dragging and dropping works for me. Yeah, cool. And it's super easy to just drag and drop anyway. So if you see here, we've got sidsmooth.obj, which is just my face that I 3D scanned using the Revo scan, the Pop2 scanner. And we talked a little bit about like vertices, vertex points. That's what makes up a digital object. So here you can see all of the points. And if you see the points here, you know you've done something right. And there's like a ton of them because it's a pretty complex, like the face is kind of complex, right? So there's a bunch of points. It's a SID smooth because I actually did smooth out the object after, like in a post-processing software. So cool, let's go to Sketch, and we will come up top and create a variable, say let face, I guess, because it's my face. And in the future, it will be yours if you scan yours. And then we need our function preload again. And face equals loadModel. We can put sid smooth.obj. And don't forget the little tick marks around it. Cool. And then we'll put true. So we'll come down into the draw and we'll just say model, and we'll put our variable named face. And now it should appear if we have in the extensions installed live preview by Microsoft is what I use and what the class uses. So going to the Explorer and just right clicking on the index.html, and it's saying show preview, and a window will pop up in the right, and it'll kind of just show you what you've got. So so I'm not seeing anything, unfortunately. Oh, it's because I haven't changed the create canvas to make it WebGL. So just add a third parameter, WebGL, in all caps. It might take a second. I don't know. Yeah, there we go. Okay, cool. So there she is in all her glory. But she's upside down and she's very dark. So if we recall, we're going to use the rotate functions, and if we're rotating it on the x-axis, we want to flip it upside down, we need to do rotate x. We'll do like a variable of c1, and we'll say desaturated 50 and 100, and then 0.5 for the x direction, 0.5 for the y direction, and a negative 0.5 for the z direction. And let's create c1 equals 0, and just animate z1. So I like to make a little section for animation. So c1 plus equals 0.5, and then c equals c modulo 360. Fun fact, if you want to not cycle through like a rainbow of colors, but if you want to cycle through like a specific set of colors that you've declared, you could make a color array. And I haven't done a demo on color arrays, but I have done a demo on image arrays, and they work very similarly. And I really need to make a demo on moving the index value of the array. So basically you make an array full of all the colors that you want, and then you read through that array and you create like an index variable, and you just cycle through the index number. So sometime I will do that and make a video for y'all, but not yet. So cool. Oh, we have to put C1 and C1, and we're still not seeing much. What am I doing wrong? Not sure yet, but let's go ahead and scale the face up a little bit. There we go, scale function. And I'm gonna say width times 0.1 and see what happens. Ooh, that's very big. So let's do 0.01. I see why it's taking so long is because we've got the stroke on it. So let's actually do no stroke, because I think that will save us some time. There you go, yeah. So make it a little smaller actually at 0.5. It's looking better, and it's loading faster now that the stroke isn't there. So keep that in mind. No stroke helps it load. All right, so now let's go ahead and instead of rotate X 180, let's go ahead and use the rotate X, rotate Y, and let's do rotate Z. Let's just do all, we're rotating on all axes. We are going to use frame count. There we go. So it's moving slower. We can see all the different parts of our OBJ, but say we wanted to add another animation and we wanted that animation to go faster. Like I think using frame count is just gonna be like, if you want something more complex, you might just use a variable instead. And we could potentially like make it interactive by doing a number of things. What shall we do? To make this quick, we'll just make it interactive by using the orbit control function. So interaction orbit control. I think that's how you Might want to go and check the references. Oh, we have to capitalize the C. Duh. Allows movement around a 3D sketch using the mouse or trackpad or touch. So that's cool. Left clicking and dragging or swipe motion will rotate the camera position about the center of the sketch. Right clicking and dragging or multi-swipe will pan the camera position without rotation. So it does that basically. Here you can change the sensitivity, and now I can move it, and I can right click and pan. And what does the middle one do? Just middle? No, just the left click rotates and right pans it. Oh, and you can scroll in. That's cool. Yeah. So you can use the scroll wheel. Neat. Yeah, I'm gonna change the background color real quick and call it a day. You come up here, and it's on our local server, so we can't like really share this, but we can display it on our own computer or laptop by opening in browser. Click this little hamburger thing, open in browser, full screen. I'm on a Windows, so F11 and then F5 to refresh, and it should scale. And since we have orbit control, we can easily like scroll in and out. So that's pretty neat. Yeah. So you've got, you know, a face that you can move around and interact with, and it's animated and it's full screen. So there you have it. That's how to use OBJs or loading models using the p5.js library. Yeah, link me to some of what y'all make. If you're not in the class, I'd be curious to see if people from the outside do something with this too. All right, thank you.